Welcome everyone to today's video. So this video is regarding Discord Witness Days, which is our video to discuss questions in our Discord group. So in this video we are going to start with only two questions. So one of the questions which we are going to discuss today is that of a charged particle enter a magnetic field. So let us do what is in that question. So we have a charged particle, charge q, and there is a magnetic field present in space. So the magnetic field is probably inward, and the charged particle is entering the field at some point, grazing the field at its lower interface. So let's say this is some x-axis and this is some y-axis. So we are given that the field is in a region of width mv by qb divided by 2. This is the width of the field of the region, mv by 2 qb, and we are given that the velocity of the charged particle is some v, it is some v I cap. So it enters the field at some point, let's say origin, and then it will take a circular path and it leaves the field at some angle, and it leaves the field and goes ahead. It will go ahead in a straight line. So this is what we know, quite common phenomena in magnetic field. When a charged particle enters perpendicular to magnetic field, then it experiences a force perpendicular to velocity, which is given by qv cross b or qvb sine theta, which is which acts in a certain way such that it is always directed towards some particular point. So our objective in this question is that when the particle is entering in this question, in this region, our objective is to find the acceleration of the particle at the point at which it has left the field. So this acceleration vector which the particle would be experiencing at all points, which would be directed towards the center of the circle, somewhere here, let's say this is the center of the circle. So this is the topmost point. This is what we are saying is the center of the arc which the particle has traversed. So what is the acceleration vector of the particle when it has just left the field? So this is what we have to find. So acceleration can be found by using what the formula for force of the acting on the particle, because acceleration follows the Newton's second law. So we can say the force acting on the particle is equal to some qvb sine theta, where theta is the angle between velocity and magnetic field, which is 90 degree, and this is equal to mv square by r. So from this we can easily comment that the acceleration of the particle, which is the centripetal acceleration, is equal to q v magnetic field b divided by mass of the particle. So we have determined the acceleration of the particle in terms of its magnitude. What would be the direction of acceleration of the particle, that we have to find. So we are given the value of this width of the region of the magnetic field, that is d, and what is the radius of the circle in which the particle goes. The radius of the circle in which the particle is going is actually mv by qb, which is 2 times the value of d which is given to us. The value of d is given to us as mv by 2 qb. So it is 2 times the value of the radius of the circle, which is mv by qb. That means this complete distance, that is from the center of the circle to the circumference of the circle, that complete distance would be composed of 2 d's, because 2d is equal to r and this distance is again radius of the circle, that is d. So is 2d, because this is the radius of the circle, this distance is again 2d. I hope that particular thing is clear, that the radius of the circle is 2d. So this distance is 2d. From that we can find this particular angle theta. So this angle theta is very easy to find. It is actually 60 degree. So the angle which the acceleration vector makes with the horizontal is simply 30 degree. So we can say the acceleration vector of the particle is the qvb by m value, that is the acceleration, and the direction in which acceleration is taking, that will be minus cos 30 degree I cap and plus sine 30 degree j cap. So this would give us the acceleration vector of the particle when the particle has just left the magnetic field. So let us move on to our next question. So in our next question, we are going to discuss the concept of the galvanometer. So galvanometer is something which responds to the amount of charge flowing through it. And why is that? Why does it respond to an amount of charge flowing through it? It responds to because the mechanism or the functioning of galvanometer depends upon a coil. For a galvanometer in olden days, especially, what we used to do was we used to wound a coil around the core, and that coil is suspended in the magnetic field. So that thinking you can relate with what you learnt in AC motors or AC motors or DC motors, that the coil is suspended in the field and the magnetic field is passing through that particular coil. Now when some current is passing through that particular coil, then that coil is deflected. So that is the whole point of a galvanometer. The deflection is because of the current passing through the coil, right? So what do we do to produce current in the coil? Some charge is passed. So that's why we say when a charge is passed through a galvanometer, there is some deflection. So what the question is? The question goes something like this, that the galvanometer is of some resistance. Let's say the resistance is given as some 18 ohms, I think, and some current is flowing through it, and it is showing some deflections in it, and that is 30 deflections. Now the galvanometer is shunted by a resistance of 12 ohm resistance. So it was already having an 18 ohm resistance. Now it is shunted by a 12 ohm resistance galvanometer, and now it is now the same current is passed through it. Now this fact that the same current is passed through it is not given in the question. So the whole question hinges about that idea only, that should we assume that same current passes through the galvanometer or not. So let us first draw what is in the question. So question is saying that a galvanometer of resistance 18 ohm shows a deflection of 30 divisions. Now it is shunted. So first let us do the question. So let's say this is our galvanometer, and it is of 18 ohm resistance. Now usually when we are solving the questions of galvanometer, it is kind of given that you have to take that the constant current is being supplied, or some fixed amount of current is being supplied to the galvanometer, or some fixed voltage, and the galvanometer is rated, or the measurements are being taken at same current. That is actually what is given, that all the measurements in this galvanometer are taken at this particular current. The galvanometer responds to this current for this particular deflection. So it is given in the question that what is the full scale deflection current of the galvanometer, or what is the half scale deflection current of the galvanometer. In the same way, it should be given in the question that what is the full scale voltage, full scale deflection voltage of the galvanometer, or full scale half scale deflection voltage of the galvanometer, which is missing in this question and which has caused this question to be misunderstood. So what is happening is that the divisions by which the galvanometer has deflected upon passing some current through it is 30 divisions. Since we are not knowing that it is a full scale deflection or what, we do not know anything about it, that how much current is passing. So we are just saying some current is passing through it. So 30 divisions for deflection is there when 18 ohm resistance is there, and now we have shunted it with a new 12 ohm resistance. And now it is asked that how many divisions of deflection would be there in the galvanometer. So we would have to assume the amount of current passing through the galvanometer is constant. Now what we can add to is that options are given in this question, and options are given like 0, 10 division, 12 division and 18 division. So there is no option like 30 division, right? If it were that kind of galvanometer, that full scale deflection of full scale deflection happens at this particular voltage. If it were this kind of question that the galvanometer is responding to voltage applied to it, then there would have been some option that the deflection in the galvanometer would be 30 divisions only, because question would have been easier in that case. But there is no such option in this particular question, that all the options are 0, 10, 12 and 18. That means that is not the case the question is referring to. So we have to assume that instead of taking the constant voltage case, it is a constant current case. So the current passing through the galvanometer in the previous case when the 30 divisions were being deflected would be same as when the galvanometer shunted with a 12 ohm resistance. So what we do to solve this question is, we will be saying that some 30 divisions are being deflected, to multiply it with some constant k, that would give us the amount of current passing through the galvanometer earlier. So this is the whole current which is passing through the galvanometer, that is 30k. Now it is being divided through 12 ohm and 18 ohm resistance. So let's say some theta deflection is happening in the galvanometer. So the amount of current passing through the galvanometer is some theta k. So theta k into 18, that would be the potential difference across these 2 points, and that would be equal to the rest of the current passing through the 12 ohm resistance, that is 30 minus theta k. That would be the amount of current passing through this galvanometer, 30k. From that 30k, 8k current has gone straight up, the rest of current is going through 12 ohm. So the voltage drop across 12 ohm resistance is this, and since they are in parallel, voltage difference would be same. This yields us as a result that the deflections happening in the galvanometer would be some 12 deflections. So this was the point of the question, that sometimes question is missing in its language in the question itself, but we can solve the question by looking at the options. So thank you for joining and have a great day.